In the previous video, I did my best to explain how we are going to ensure that we place the correct wall type tile at the side of our floor tiles, depending on the floor tiles surrounding this wall position. In this video, we are going to prepare our logic. First of all, I have mentioned that we will need to download a script containing a list of binary values that will be responsible for checking against the types of wall tiles. So let's go into the GitHub repository. The link will be in the description of this video. Great. It contains multiple hash sets of binary values that we will use to create an appropriate type of wall tile at the appropriate space on our tile map. So what we can do is go to the end and select everything, since we cannot really download one file from GitHub. So let's copy this script, Ctrl+C. Let's go back to Unity. Great. Let's go to our scripts folder, right click, create, new C# script, and let's call it wall types helper. And let's open this script up in Visual Studio. Great. What we can do is to paste what we have copied below the class definition. Let's slide up, since now we have two classes here. Let's make sure that we copy the name of the class that we have created in Unity and paste it instead of the name of the class that we have copied. So this will be public static class wall types helper. And let's delete what we have pre-created for this file. So now we end up only with the code that we have copied from the GitHub with the changed class name, so we ensure that this is the correct name. Let's save this file. And this file, as I have previously mentioned, will contain different hash sets of binary values that will correspond to the given type of the wall that we will want to place. And we have corners. We have the wall diagonal corner up left, up down right, down left, up right, wall full, and all the other types. And we are going to implement this script into our project, into our wall generator in this video. For now, let's go back to Unity. Great. And let's open the wall generator script. Okay. So right now, what we are doing is we are only finding the walls in the directions, so the wall positions, in the find walls in directions method, and we are returning this value, or rather this hash set, and we are using for each loop to loop through each position that was returned and painting there our basic wall tiles. Now instead of this, we will have to pass to our tile map visualizer the list or the status of the neighbors of each wall position, so that our tile map visualizer can use the newly created wall types helper script to decide what type of wall tile should we place on a given position. Before we can add logic here, we will have to visit our directions to the script. So let's right click on it and select go to the definition to open it up. It is still placed in the procedural generation algorithms script. What we will want to do is we will want to add two more lists to this script, or to this class rather. We are going to copy this cardinal directions list. Let's copy it, let's paste it below. Let's change the name to the diagonal directions list. Great. And what we are going to do is we are going to pass a specific values. For the first value, it will be 1 on X and 1 on Y. It will be up, right direction. The one below it will be 1 on X and -1 on Y. It will be right down direction. The third vector to int value will be -1 on X and -1, so it will be down left diagonal direction. And the last one will be -1 on X and 1 on Y to create left up diagonal direction. And this will be the diagonal directions list that we will use to detect the wall tiles that contain a floor type in a corner of it, in the diagonal direction from it, so that we can use the corners and the different set of wall tiles to populate those wall positions. And at the end, we will create a list of both of those so that we can find the neighbors in 8 directions to find out which exact type of wall tile should be placed. So we are going to create public static list of vector to int, and we are going to call it 8 direction list or 8 directions list equals new list of vector to int, and we are going to open the parentheses, and let's copy the values from the cardinal directions list and paste it here. And in between those directions we are going to paste to create spaces, and in those spaces in between the up and right we are going to paste up a right direction. In between right and down we are going to paste right down direction. In between down and left we are going to paste down a left direction, and at the end we are going to paste a left up direction. And this is all. Remember to add comma before the last vector to int to add the last one here. And this will be the order of those vector to ints will be important because we want to still go in the clockwise direction, in the clockwise manner, so that we exactly know which byte in the binary value represents which position, so that we can create our list of binary values in our wall type helper. So actually this was already created, so that each value represents the appropriate direction, also in a clockwise manner, starting from the up direction and ending into the left up diagonal direction. Great. So make sure that you use Ctrl-Shift-S to save your directions to the class, and let's go back to our wall generator. I have it opened in Visual Studio. And now, first thing that we can do is to reuse the find walls in directions, since we have passed here the list of vector to int directions list, so that we can not only find the basic wall positions, but also var the corner wall positions equals find walls in directions. We are going to pass the floor positions, and we are going to pass the direction to the dot diagonal directions list, so that we can place some basic walls using these basic wall positions, and then we can focus on placing the appropriate corner tiles in those positions. Now, since we want to separate this code from the code that actually creates those tiles, we are going to select the for each loop, right click, quick actions, and we are going to choose extract method, and let's name it create basic walls method. So create basic walls, enter. And what we are passing here is our tilemap visualizer, our basic wall positions. And in addition to that, we will have to pass here our floor positions as well. So let's select the hash set vector to int floor positions and paste it inside our definition of create basic walls at the end. Let's paste it as a new parameter. And in our create walls method, for the create basic walls, we are going to pass at the end our floor positions list hash set of vector to int. And now we can here check against the floor positions the neighbor's status of our wall positions. So what we are going to do is basically check in which direction from our wall position are floor tiles, and we are going to pass the status saved as the binary value to our tilemap visualizer for further processing. We are going to stay with our for each loop here. We're going to search for position in our basic wall positions. But here, before we visualize using the tilemap visualizer, we are going to create a string, neighbors, maybe let's call it neighbors binary type, or binary value, and let's set it to be empty string. Now, we are going to loop for each, tab to create it, var direction in, and we are going to again call directions to the dot cardinal directions list. So we are going to basically check in each cardinal direction the neighbor from the position of the current wall that we want to place. So type var neighbor position equals the position of our wall plus the direction. This will give us the position of our neighbor. and we are going to check if our floor positions dot contains the neighbor position. If it does, we are going to type neighbor's binary type, so this is a string, plus equals, and we are going to type simply 1, since we want to add 1 to our position, to our neighbor's binary type. Else, we are going to add neighbor's binary type plus equals 0. And at the end, after we loop through each direction and check the neighbors, for the tilemap visualizer, we want to call paint single basic wall, and we are going to pass not only the position, but also the neighbor binary type. Okay, since it doesn't work like right now, let's right click, go to the definition of this paint single wall basic wall, and what we can do is add here a string, and let's maybe call it binary type. Okay, and this should be it. Now, since it will take some time to implement the code into our tilemap visualizer, let's go back to our wall generator. I have it opened in Visual Studio, and let's finish implementing this class first. So right now we have created our basic walls. What we want to do as well is at the create walls method, we want to call create corner walls. And this method will take the same parameters as our create basic walls. So let's copy the parameters and then let's paste them here. And this will be responsible for creating the corners as well as modifying the previously placed basic walls if they are incorrect. So if the type is incorrect. So let's alt enter on the create corner walls, and let's generate this method inside our class. It should appear somewhere below the create walls. And here we are going to create for each loop, tab to create it, var position, tab to move to the collection, in our basic wall positions. But we do not want to pass here the basic wall positions, but instead we wanted to pass here our corner wall positions. So I'm going to change in the create walls, instead of basic wall positions, we are going to pass to the create wall positions the corner wall positions, and let's change the name of the parameter in create corner walls to again corner wall positions, and we are going to loop through this list that we have found using the diagonal directions list inside our find walls in directions method. So we are looping through the positions of walls that have in its diagonal direction a floor tile. So now again we are going to create string neighbor's binary type equals empty string, and we are going to call for each tab, and let's create it var direction in, and we are going to type directions to the dot the 8 directions list. So this will be the 8-bit binary value. And what we are going to type here is var neighbor position equals again the position of our wall plus equals the direction. And again we are going to check if the floor positions dot contain our neighbor's position. I have made some mistake here. Positions plus direction. If our floor positions that contain neighbors positions, again we are going to add to our neighbors binary type plus equals 1. Else we are going to add to our neighbors binary type plus equals 0. And again this will create an 8-bit binary value in a string format that will represent the neighbors in the clockwise direction, starting from the up direction and ending in the left up diagonal direction. So again, we will need to call a different method now inside our tilemap visualizer. So let's type tilemap visualizer, and we will need to call paint single corner wall. And again, we are going to pass here the position of our wall as well as the neighbor's binary type. Okay, let's save it. Alt enter on the paint single corner wall. And let's choose a generate method inside our tilemap visualizer. And let's save the wall generator. What we can do is right click on the paint single corner wall and select go to definition. And we are going to implement this method as well as modify the paint single basic wall method in the next video. For now, let's simply delete the throw statement, let's save it. See you in the next video.